Okay, so now we are on to a quite simple question, right? We're given that a tiny spherical raindrop of this diameter is falling, and specifically, we are asked to calculate its terminal velocity, right? Terminal speed, and we are given information about its diameter. We're told to assume that the drag force is linear with respect to velocity, right? So that's an assumption. um, in reality it's actually a dependence of velocity squared and whatnot, but in this case, right, like most physics Olympiad questions, they will tell us the dependence, right? They'll tell us what to assume, right? And we're even better, you're even given the coefficient, right? So given the velocity, you know exactly the drag force. Okay, so what's its terminal speed, right? So recall that the terminal velocity is the velocity that makes the net force 0. So the raindrop is falling and it has gravitational force acting on it, mg, and it has drag force, right? F drag is equals to cv, right? Where v is the velocity of the raindrop. So the terminal velocity is the velocity that makes the net force 0, and hence the terminal velocity satisfies the following equation: c v terminal equals to mg, right? If these two are equal, right, then the net force is 0 and the velocity, and since the net force is 0, acceleration is 0, right, by F equals ma, and since the acceleration is 0, the velocity doesn't change. So terminal velocity would stay, right? It will stay at that velocity. It will not change. That's what it means by terminal velocity. Right? It's the final. Terminal means final, right? So yeah. Okay. So yeah. So we know C. We want to find V terminal. We know G, right? We just need to find M. And thankfully, we're given the radius. I mean the diameter, right? So mass can just be found by 4/3 pi r cubed times the density of water, right? Because rain is made of water. So this 4/3 pi 0.1 divided by 2, sorry, 0.1 mm, right? So we need to be careful about the units. 0.1 mm, 0.1 times 10 to the minus 3, right? We're always working in terms of meters. Divided by 2 cube times rho. What is rho? Rho is 1000 kg per 1000 kg per meter cube. So this is 1000, right? Okay, so if we calculate this out, we get 3, punching the calculator. This is 5.2360 times 10 to the minus 10 kg. Okay, that's quite a small number. Okay, so with this, we can substitute it back into the equation. So V terminal, right, just need to take mg over c. So this is this m times g, 9.81 over c, and c is given over here, 1.55 times 10 to the minus 6, and we get the answer of 3.3 times 10 to the minus 3, right, meter per second. We always work in SI units, so the answer is B. So that's how you do this question. Yeah, simple enough.